Hello everyone, my name is Elena Yang. I am from 10A. This is my AP Physics 1 final project. My topic is Aurora, and my instructor is Mr. Shahid. I'll give you a brief introduction in this poster. Aurora is a brilliant natural light in the sky. It's also known as the aurora borealis or polar lights. It frequently emerges in Arctic regions, with a variety of lovely light patterns. There are some causes of aurora: solar wind, Earth's magnetosphere. Aurora is formed when the tiny particles, which is the solar wind, interacts with Earth's magnetosphere. When we look at the sky, there are some colors of aurora: green, blue, purple, red, and pink. There are also other factors about aurora. It is discovered by Galileo Galilei in the 17th century. Auroras can change with time during the night. Auroras can be seen on any planet with a dense enough atmosphere that is in the path of the solar wind. So this is my poster, and my presentation will also contain these 4 parts. This is my presentation, Aurora. First, please see some pictures about aurora. This is the blue aurora, this is the green aurora, and this is the orange aurora. Then, this is my driving question about aurora. As you can see, there are different colors of aurora, but how does the aurora create different colors in the sky? First, I will give you an introduction of aurora. What is aurora? Aurora is a brilliant natural light in the sky. It's also known as the aurora borealis or polar lights. It frequently emerges in the Arctic regions, with a variety of lovely light patterns. Aurora is seen only at night. It is colorful with many different colors such as green, blue, purple, red, and pink. It is the sun which actually causes the appearance of aurora. This is aurora. When you climb a mountain, you can see it. You must be wondered, but who discovered aurora? It is Galileo Galilei. The astronomer and scientist Galileo Galilei termed this phenomenon the aurora borealis in the early 17th century. Boreas was the Greek word for the north wind, and the Roman goddess of dawn was Aurora. So Aurora is represented by the Roman goddess of dawn. My second section is Aurora's formation. In this section, I will tell you what factors can form a aurora. What causes aurora? In the ionosphere, solar wind ions collide with atoms of oxygen and nitrogen from the solar system. The solar wind comes to the Earth's atmosphere and collides with the oxygen and nitrogen from the solar system. An aurora is a magnificent glowing ring that's surrounding the poles created by the energy released during these collisions. So it is exactly the collisions between atoms of oxygen and solar wind ions that create aurora. Aurora has different forms on different planets. In the Earth, we can see this kind of aurora, but on different planets, we can also see aurora. So, Aurora can be seen on any planet with a dense enough atmosphere, that is, in the path of the solar wind. The aurora oval is dramatically deformed on planets with magnetic axes that are significantly diverging from their rotational axes, whereas Venus has no magnetic field and hence experiences irregular-shaped auroras. So sometimes we can see regular-shaped auroras, but sometimes the shape of aurora is irregular. This is aurora on Mars. This is aurora on Earth. We usually can see this kind of aurora. And this is aurora on Jupiter. Look, different planets has different forms of aurora. My third section is aurora with different colors. How does aurora create different colors? Look, there are several different colors of aurora in the sky. This is green. This is blue. This is purple aurora. This is red aurora. And this is pink aurora. This picture shows what condition can create what kind of aurora. In the ionized nitrogen, we can see aurora with purple and blue color. In excited oxygen, aurora is green and red. In excited nitrogen, we can see red aurora. So, a gas spectrum refers to the distinct hues of light it produces. The colors of the aurora lights are governed by the wavelengths of gases which are in the Earth's atmosphere, and also the height where most impacts occur. At different heights, inbound particles hit with various gases. Aurora. The majority of aurora characteristics are greenish-yellow. This is greenish-yellow aurora. Although the towering rays can occasionally turn red at their summits and at their lower borders, sunlight will occasionally strike the upper half of the aurora rays, producing a faint blue tint. On extremely rare occasions, the aurora can turn a deep blood crimson color from top to bottom. This is red aurora, crimson color, from top to bottom, which happens nearly once 10 years. Pink color can also be visible in the aurora's lower region. The powerful aurora collisions not only produce light, but they also carry heat. Infrared radiation dissipates the heat, and powerful winds in the upper atmosphere move it away. As I said before, different height, different color. This picture explains why aurora can have different colors at different heights. When various gases are agitated, they emit distinct colors at a height of 100 kilometers. Oxygen emits a yellow-green tint. Here, the aurora is green or yellow, whereas at a height of 200 kilometers, oxygen emits all red auroras. Above 200 kilometers, the aurora is red. Neutral nitrogen emits red-purple light with wavy edges, whereas ionic nitrogen emits blue light. Consider what the atmosphere would be like if it were comprised entirely of neon and sodium. Auroras would be red, orange, and yellow. So, in our daily lives, where can we see the auroras? We can see aurora from a park. This is a river in the Wanyuan National Park in Minnesota. We can see auroras here. We can also see aurora from a hotel. This is Svart Hotel in Norway. This is the hotel, and when you lie on the bed, you can see aurora in the sky, which is very beautiful and magnificent. Additionally, we can see aurora from a plane. This is a new way to see aurora. This is the aurora. We can sit here and watch the beautiful scenery. This is Hecla Aurora Plain. So, at last, this is my reference website about Aurora. Thank you for watching my AP Physics 1 final project, Mr. Shahid.